Hi, welcome to Parametric House. In this Paracourse lesson, we're going to learn how to produce two set of benches from scratch. The first one we're going to talk about is assume we have a line. We're going to define a height for it, a thickness. There are going to be two parts, which we're going to make a gap, which is going to be the distance between the first part and the second part. Obviously, the second part can't reach and go towards the thickness, so we're going to talk about how we can fix that. And also there is a parameter like this, which is a subcurve, and we're going to select a part of the top and the bottom so we can have more control over our design. So this is going to be the first lesson we're going to talk about, and at the end you can see that we can bake these two. So you can bake them into two different layers. A good thing about this algorithm is that you can give it to multiple lines. So for example, if I just draw 3 lines and give it to the input, you can see that it's going to produce it on those 3 lines. We're going to talk about the data management because it's going to be a little bit complicated to manage them, but we have to fix it. So we're going to talk about that lesson too. The second lesson is a really quick addition to this one. So what we have to do is to give it a line. For example, you can see if I change this line, it's going to update. We're going to talk how we can control the parameters here. As you can see here, we can define the thickness, where we want to twist it. So it's going to be a good lesson for those who want to make a parametric bench of like a twisted solid. And we can also control this height. So as you can see here, we're going to get a distance from here to down here and say that the distance is this number, so we can control it in our project. Here you can see that we can get the final result and extract the solid in Rhino. Okay, let's get started from scratch. What I want to do is to draw a line in Rhino, so it can be any line you want, and we can go to the params menu, pick up the geometry curve, and right click and set one curve. So this is going to be imported into Grasshopper. After we have defined this line, there are some things that we have to find. One is the normal direction of this line, because for example, when we want to give it a thickness, we have to have this one, is to go to the curve, analyzes, and use this horizontal frame. Just give it to the curve or line. We have to reparameterize it so it's between 0 and 1 so we can control it easier. And I usually give it a 0 just to show you that it's going to give you the plane. Let's make the plane a little bit bigger, so I'm going to make this 10 times bigger, and that is going to be the plane we're going to work with. We need the X direction, the Y direction, and also the Z direction to work around it. Okay, the next step is to define the height. So I'm going to say, for example, 12.5. I usually use this number because it's a number between 0 and 100, so we have a bigger number slider. So I'm going to say this is the height, and we're going to also define a gap. So there is a gap, and there is also a thickness. So again, we can just copy paste this and say this is the thickness. I think that these 3 parameters are enough for making the parametric bench. So now let's go and make it. First of all, I'm going to use the curve endpoints. Just put this up here so we will use it later. Give it to the curve to get the start and the end, and assume we want to have the height on the start, so we have to define that. You can go to the curve and use this line STL component. Let me put the full names on so you can see here the inputs and outputs. Okay, the start is going to be the start point of the line. The direction is obviously the Z direction, but if you want to actually change it with a plane or something like that, I'm going to put this into a plane, and if you give a plane to a direction, it's going to automatically pick up the Z direction of that plane. So that is also a quick tip you can use if you want to use the normal direction of a plane. The length is going to be the height we want to have. So as you can see here, we can control the height. And then we want to use this line to go for the end. Again, we're going to go to the curve, endpoints, This time the direction is going to be the X, so we have to go to the vector plane, deconstruct plane, and use this X axis. Okay, so I'm going to multiply that. The length of the line, we can just connect a number to it. It's going to get the length. And if I just multiply that with the length, it's going to go completely at the end, right? Why not we just multiply that with a number between 0 and 1? Obviously 0 is not correct because we don't want to make it 0. 0.1 to 1. That is going to give us complete control over this line. Let's go to the curve. Line STL again, the start end, this time is going to be end of this line, right? The direction is going to be the x-axis, and the length is obviously going to be, if I give this to here, you can see that we can control that. Obviously we didn't need to multiply that with an x-axis because this is a length factor, so we can just delete this one and say, okay, I want the length multiplied with a percentage. So that is going to be 100%, this is 10%, and that is going to help you to make the top part of the cantilever part.